Good morning, student. Today we are going to see the MSc syllabus of Amravati University. Same first. Same first, paper 1, that is Inorganic Chemistry 1. Unit 1 is Stereochemistry and Bonding in the Main Group Elements, Whisper Theory, prediction of shape of irregular molecules and ions like SbF4, SF5, SFS, SEF, ICH, IFA, IOF4, NH2, PCl2, PCl, etc. Drawbacks: Bend rule, energetics of hybridization or d orbitals, participation by nonmetals, example showing p pi p pi bond, p pi d pi bond, and d pi d pi bonds. Second is B part from this unit, molecule, molecular orbital theory. Molecular orbital representation of polyatomic molecule with special reference to CH4, NH3, H2O, PF5, SF6, B2H, and CO, and delocalized molecular orbital of zone of ozone, carbon dioxide, nitrite, nitrate, and benzene. Unit second is metal ligand bonding. A part, recapitulation of CFT, splitting of d orbitals in octahedral, square planar, tetrahedral, square pyramidal, and trigonal bipyramidal complexes. John Taylor distortion, spectrochemical series, Nifloxictic series, measurements of CFSE in a weak, strong ligand fields. Structural consequences of crystal field effect, variation of latic energy, and heats of hydration across first row transition metal ions, stabilization of unusual oxidation state, and ionization energies, structure of minerals, spinels, limitations of crystal field theory. B part of second unit, molecular orbital theory of coordination compounds. Theoretically, failure of ionic model of CFT, experimental evidence in support of metal ligand orbital overlaps, adjusted crystal field theory, composition of ligands group orbital, SALC principle, molecular orbital energy diagram of octahedral, tetrahedral, square planar complexes, including both O and A bonding, angular overlap models, comparison of CFT, LFT, and MOT. Unit 3 Boron hydrides and metal cluster. Boron hydride classification, nomenclature, structure, bonding, and topology of borons. Four-digit codes, that is STYX, numbers for B2H6, B4H10, BH, BH1, and BOH1O, and their utility. Chemistry of diborane, acquaintance with metalloborane, carboborane, and metallocarbones. Preparation, structure, and bonding in non-carbonyl metals cluster, that is binuclear, trinuclear, tetranuclear, and hexanuclear ions. Preparation properties and structures of zintyl ion and cation of metal GeSN, Pb, Sb, and bismuth. Metal cluster. Occurrence of metal-metal bond, binuclear, trinuclear, tetranuclear, and octahedral cluster. Synthesis properties and bonding of carbides, sulfur, nitrogen compounds, peroxo compounds of boron, carbon and sulfur, oxyoxide of nitrogen, isopoly and heteropoly acids. Macrocyclic complexes. Types of macrocyclic ligands design and synthesis by coordination, template effect, di and polynuclear, macrocyclic complexes, application of macrocyclic complexes. Unit 4th, non-aqueous solvent behavior. Inorganic solutes, inorganic solvents, solvent system concepts, the role of solvents in chemical reactions, effect of physical and chemical properties, inorganic reactions in the following non-aqueous solvents: dinitrogen tetroxide, anhydrous sulphuric acid, bromine trifluride reaction in molten salt and ionic liquids, and supercritical CO2 as solvent. B part, metal ligands equilibria in solution. A brief introduction to complex equilibria, outline of thermodynamics, stability of metal complexes, and factor of fitting that such as temperature, dielectric constant, and ionic strength, nature of metal ion and ligand, statistical electrostatics, chelates effect, experimental method for the determination of stability constant by spectrophotometric method, that is Jobs and mole ratio. Bjerrum pH metric method, polarographic method, and conductometric method. Relation between thermodynamics parameters and their importance in complex formation. Protonation and dissociation constant of ligands and their relationship mixed ligands complex and application of mixed ligand complexes. General treatment of the determination of formation constant of mixed ligand complexes. Unit 5, System and Group Theory. Introduction to system elements, symmetry operations, product of symmetry operations, equivalent symmetry elements and equivalence atoms, point group, classification of point groups, Scoian, Scoian-Flies symbols, identification of point group of simple molecules like HCI, BeF2, CO, H2O, NH3, CO2, BF3, C2H4, C2H6, C2H2Cl2, C6H6, PCl3, PCl5, PTCl4, PTCl2NH3 by 2, COCl NH3 by 4, FEF, substituted benzene molecule, pyridine, ferrocene, SF4, IFS, etc. Necessary conditions for any set of elements to form a group, subgroup, classes in a group, application of point group, group multiplication table, matrix, representation of symmetry elements, reducible and irreducible representation, characters of matrix, conjug- conjugated conjugate matrix, properties of irreducible representation, great orthogonality theorem with proof and its importance, construction of characters table of C2V C3V point group, Mulliken symbolic Mulliken symbolism rules for irreducible representation and its application with examples. Paper 2, Organic Chemistry. First, Unit 1, Nature and Bonding in Organic Molecule. Delocalized chemical bonding, conjugation, cross conjugation, resonance, hyperconjugation, bonding in fluorines, fluorines, strength of acid and bases, cryptands, inclusion, compound, cyclodextrious, cationous, and rotaoxens. Aromaticity in benzonite and non-benzonate compounds, alternates and non-alternates hydrocarbons. Huckel's rule, energy level of pi molecule orbitals, annulines, anti-aromacity, homoaromacity, aromatic characters and chemistry of cyclopentadienes, anions, tropylium cation, tropine, tropine and propylene, anti and homoaromatic system, NMR as a tool for aromaticity, conformation, conformational analysis of cycloalkanes, de- declines effects of conformation on reactivity, steric strength due to unavoidable crowding, conformation of glucose. Unit 2 Stereochemistry. Interconversion of Sohor's, Newman and feature projection. Chirality examples from common objects to molecule. Axis, plane, center, alternating axis of symmetry. Stereoisomerism. Definition based on symmetry and energy criteria. Configuration and configurational stereoisomers. Center of chirality molecule with C and S based chiral center. Absolute configuration. Enantiomer. Racemic modification R and S nomenclature using Ingold Prelog rules molecule with a chiral center and CN axis molecule with more than one chiral center. Thero and erythroisomers method of resolution, optical purity, anisotropic and dystereotropic atoms, group and phases, prochiral relationship, stereospecific and stereoselectivity with respect to substrate, stereoselectivity, product, stereoselectivity, anisoselectivity, diastereoselectivity. Synthesis. Asymmetrical synthesis. Axial, planar, and helix chirality. And examples. Stereochemistry and absolute configuration of allenes, biphenyls, and binacthyls, and ANSA and cyclophenic compounds. Spirins, exocyclic, alkylating cycloalkenes, topicity, and prostereoisomerism, topicity of ligands and phase and their nomenclature. NMR distinction of anisotropic, diastereotropic ligands. Unit 3 Reaction Mechanism Structures and Reactivity. Types of mechanism, types of reaction, thermodynamics and kinetics requirements, kinetics and thermodynamic control, potential energy diagram, transition state and intermediates activated complex, method of determination mechanism, kinetic isotope effect, Hammond's postulates, Curtin Hammett principle, effect of structure on reactivity, resonance and field effects, steric effect, quantitative treatment, a Hammett equation and linear free equation energy relationship, substituent and reaction constant, Taft equation. Unit 4th Aliphatic nucleophilic substitution. The SN1 SN2 mixed SN1 SN2 and SAT and SNI mechanism. Nucleophilicity. Effect of leaving group, ambient nucleophiles and ambient substrate, regiospecticity, the neighboring group, participation mechanism, substitution at allylic and vinylic carbon atoms. Elimination reaction, the E1, E2 and E1 CB mechanism, orientations of the double bond, Stetsev and Hoffman's rule, effect of substrate structure, attacking base, leaving group and medium, pyrolytic elimination mechanism and orientation, cleavage of quaternary ammonium salt, conversion of di- vicinal dihalides and nitro compounds to alkanes. alkenes. Summary of factors controlling substitution and elimination by unimolecular and bimolecular molecule mechanism. Unit 5, Aromatic Electrophilic Substitution. The Arrhenium ion mechanism, orientation and reactivity, energy profile diagram, the orthopara ratio, ipso attack, orientation in benzene ring with more than one substituents, orientation in other ring system, diazonium coupling, Gattermann-Koch reaction, Pichman reaction, Hoban-Hodge reaction, Reimer-Tiemann reaction, Kolbe-Smith reaction, recapitulation recapitulation of halogenation, nitration, sulfonation, and Epsi reaction. B part Aromatic nucleophilic substitution. A general introduction to different mechanism of aromatic nucleophilic substitution N SNAR, SN1, benzene, and SRN1 mechanism. Reactivity effects of substrate, structure, living group, and attacking nucleophiles. The Van Richards, Sommelet, Hosser, and Smile rearrangement. Paper 3 Physical Chemistry 1. Unit 1 Quantum Chemistry. Schrödinger's equation in one dimensional box. Postulates of quantum mechanism. Discussion of solution of Schrödinger equation to particles in a three-dimensional boxes, harmonic oscillator, rigid Hautor, the variation theorem, linear variation principle, perturbation theory, first order and non-degenerate, application of variation method and perturbation method. Ordinary angular momentum, generalized angular moments, engine function for angular moment, engine value and engine value of angular momentum, poly exclusive sorry poly exclusion principle, Russell Saunders term and coupling scheme, Sclater Condon parameter and numericals. Unit 2 Surface Chemistry. Adsorption Fru- Freund- Freundlich adsorption isotherm. Lang- Langmuir adsorption isotherms. Adsorption isotherm. Estimation of surface area. BET equation. Surface film on liquids and catalytic activity at surfaces. B. Micelles. Micellization, hydrophobic interaction, critical micellar concentration, factors affecting the CMC of sulfur, surfactant counter ion binding to micelles numericals. Unit 3 Thermodynamics. Classical thermodynamics partial molar properties, partial molar free energy, chemical potential, partial molar volume, and partial molar heat content, and their significance, determination of these quantities, concepts of fugacity and determination of fugacity, Debye Huckel's theory for activity coefficient of electrolytic solutions, ionic strength, determination of activity and activity coefficient. Non-equilibrium thermodynamics. Thermodynamics criteria for non-equilibrium states, entropy, production, and entropy flow for different irreversible processes. Example: heat, flow, chemical reaction, coupled reaction, and electrochemical reactions. Transformation of the generalized fluxes and forces. Phenomenological equation, micro, microscopic reversibility, and Onsager's reciprocity relation, and numericals. Unit 4th, Nuclear Chemistry. General characteristic of radioactive decay, decay kinetic, parent daughter, decay growth relationship, nuclear de excitation, secular and transient equilibrium, a particle energy spectrum, Geiger Nutta Law, theory of a band, G decay processes, fission energy, natural UR reactor, classification of reactor, reactor power, critical size of thermal reactor, excess reactivity and control, breeder reactor, reprocessing of spent fuel, recovery of UR, and plutonium nuclear weight management. Unit 5, Chemical Dynamics, theories of reaction rates, collision theory, collision rate in gases, energy requirements and static requirements, dynamic of molecular collisions, transition state theory, assumption, statistical mechanics and chemical equilibria, derivation of Eyring equation, applications of transition state theory to reaction between atoms and molecules. Example, the reaction H plus HBr, it gives H2Br, H2 plus Br. B part, unimolecular reactions. Lindman Christensen hypothesis and Hinsel Wood treatment. Marcus extension of the RRK treatment. C part, reaction in solution, solvent effects on reaction rates, factor determining reaction rate, and numericals. Paper 4, Modern Method of Separation. Unit 1, Basic Concepts of Analytical Chemistry. Role of Analytical Chemistry. The nature of analytical chemistry. The role of analytical chemistry. Con- Qualitative and quantitative analysis. Method. Classification of analytical method, classical and instrumental. Types of instrumental analysis, selecting an analytical method, analytical balance, semi, micro and micro balance, and their use in analytical chemistry. Technique of weighing and error good laboratory practice. Introduction and principle of GLP. Purification technique. Introduction purification technique for solid organic compound, purification technique for liquid, chemical method of separation and purification and criteria of purity, principle and method of sampling, theory of sampling, pitfall and problems associated with sampling, technique of sampling of gases, liquids and solid and particulates. Stoichiometric calculation based on gravimetry and trigonometric analysis of commercial samples, transmission and storage of samples, effects of sampling, uncertainties, samplers, responsibility, sampling hazards. Unit 2, Statistical Analysis. Emphasis should be placed on numerical problems, collections, treatment, and presentation of analytical data, true, standard, and observed value. Definition of terms in means and medians, error in chemical analysis, classification of error, nature and origin of error, accuracy and precision, error in quantitative analysis and their minimization, standard deviation, least square, and correlation coefficient. Confidence interval and confidence limit, graphical method of solution, parameter and variable comparison of manual means curve, and the computer program based fitting curve, test for rejection of data, T test, F test, and Q test, significant figure and computation rules, regression analysis, and statistical analysis of chemical analysis, numerical problems. Unit 3 Separation Technique Advanced level treatment of solvent, extraction, introduction, liquid liquid extraction, continuous and counter current extraction, synergic extraction, ion pair or ion association extraction, extraction by equilibrium shift, solid liquid extraction, discontinuous infused type extraction, application to the separation of alkali and alkaline earth metal, numericals. Ion exchange separation. Fundamental properties of ion exchanger. Theory of ion exchange. Exchange capacity. Screening effect. Penetration of electrolytic into ion exchange resin. Absorption of complexes. Ion. Cation and anion exchanger. Action of ion exchange resin. Ion exchange equilibria and ion exchange capacity. Strongly and weakly acidic cation exchanger, strong and weakly basic anion exchanger, liquid ion exchanger, chelation ion exchanger, technique of ion exchange, use of non-aqueous solvent in one exchange separation. In determination of total salt concentration, removal of interfering ions, separation of anions and metals, and application in analytical chemistry. Separation using solvent mixture. Unit 4th Gas chromatography. Theory and instrumentation of gas chromatography. Sample injection, splitting, split and splitless injection, column types, solid liquid stationary phases, column switching technique, basic and specialized detectors, elemental detection, chiral separation, gas chromatography, and chemical analysis, interfacing of gas chromatography with mass spectrometry, application of GLC, use of GCMS, high speed gas chromatography, gas solid chromatography, and problems. High performance liquid chromatography. Theory and instrumentation of high performance liquid chromatography, optimization of column performance, gradient illusion, and related procedures. Derivatization, mobile phase delivery system, sample injection, separation column detectors, interfacing HPLC with mass spectrometry, structure type of column packing, adsorption chromatography, bonded phase chromatography, reverse phase chromatography, ion pair, ion pair chromatography, ion exchange chromatography, size exclusion chromatography, GCMS and LCMS applications and problems. Unit 5 Chemical Safety and Handling Chemicals. Safe working procedure and protective environments. Protective apparel, emergency procedure, and first aid. Laboratory ventilation, safe storage, and use of hazardous chemicals. Procedure for working with substances that face hazard, flammable, flammable or explosive hazards, procedure for working with gases at pressure above or below atmospheric, safe storage and disposal of waste chemicals, recovery, recycling, and reuse of laboratory chemicals, disposal of chemicals in the sanitary sewer system, inci- incineration and transportation of hazardous chemicals. Explosive and chemical weapons. Chemical explosive. Origin of the explosive properties in organic compounds classification. Characterize special explosive nitrocellulose TNT picric acid preparation and explosive property of lead azide PATN cyclonite RDX dynamite cordite, and gunpowder. Introduction classification of chemical weapons, chemical warfare agent, physical and chemical properties, toxicity and data, better regulation of potential chemical weapons. Thanks for watching. Like, share, and please subscribe my channel. Thanks once again for watching my channel.